Okay, Algebra 2 fans, our topic today, notes 3-5, divide radicals, rationalize the denominator. So before we start, let me tell you your joke. Have you heard the cookie joke? You wouldn't like it. It's pretty crummy. All right, so our topic is rationalizing the denominator. So the word rationalize, you'll notice there's the word ratio in there. Ratio is a fraction. So basically what we're going to try to do is, if you have a radical like a square root in the denominator, in the bottom of the fraction, we're going to try to remove the radical. Okay, so we're going to rationalize the denominator. That means make the bottom a rational number. So directions, simplify the following expressions. Number one, if you divide a radical by a radical, and in this case they're both square roots, one thing you're allowed to do is you can write that as one big square root and a fraction, 18 over 2. So the square root of 18 divided by the square root of 2 is the same thing as the square root of 18 over 2, which is 9. So square root of 9, which we can simplify to 3. Now you can only do this if it's the same radical, if it's the same index. So you could do cube root divided by cube root. You could do fourth root divided by fourth root. You can't do it if it's, say, a square root divided by a cube root. So number 2, the cube root of 192 over the cube root of 3. Well, we can write that as the cube root of 192 divided by 3. Now we can then divide that, which actually gives us 64. 64 is a perfect cube. The cube root of 64 is 4. And that's our answer. So you're allowed to combine those if it's the same index for the radicals. Now number 3 is a little bit different. 18 divided by the square root of 2. 18 is not under a radical, so I can't just combine that with the 2. I can't say 18 divided by 2 is 9. I can't say that's the square root of 9. But we have a problem because we have a square root in the bottom of the fraction, in the denominator. So this is not simplified. If you have a square root in the bottom, it is not simplified. So what we're going to do is called rationalizing the denominator. And actually, the idea is very similar to when you add and subtract fractions. So in the top space right here, let's say, for example, you have 2/3 plus 1/4. You can't add those unless you get a common denominator. Well, the common denominator is 12, so what has to happen is we take the first fraction. To make this denominator 12, we multiply by 4, and you have to do it in the top and the bottom. So what happens, that's really like 4 over 4, so you get 8 over 12. But the key part of this is that when I multiply the top and the bottom by the same number, hey, 4 divided by 4 is really just 1. That's the number 1. And 1/4 we would multiply by 3 over 3, which would give us 3/12. But again, the idea is 3 divided by 3 is just another way to write the number 1. So what I call this, when you do this process, I call it a fancy form of 1. A fancy form of 1. It's a fancy way of saying the number 1, a number divided by itself. Well, so what we're going to do here is try to get rid of this square root. So we're going to multiply the top and the bottom by the same thing. Now we learned in the last lesson that if you take a square root and multiply it by itself, so like square root of 2, this becomes the square root of 4, which is just 2. Now the thing about this with a fraction, I can't just change the bottom. I can't multiply the bottom. I have to multiply the top by the same thing, because now I'm just multiplying by 1. And when you multiply by 1, you get the same thing back. So what this gives us, up top, is going to be 18 square root 2. Now in the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. Now, notice that the radical is no longer in the bottom of the fraction. So what we have done is we have rationalized the denominator. We've gotten rid of the radical. The last thing to ask yourself, though, is can you reduce the fractions? Now, the square root of 2, you're going to be tempted to reduce that with 2. But because this 2 doesn't have a radical, we can't do anything with that. However, we've got the 18, and we've got this 2. We're allowed to reduce that, which is 9 over 1, or just 9 square root 2. So the answer is 9 square root 2. And just like with the last set of notes, we can always check this. If you take the calculator and if you do 18 divided by square root 2, now that was the original problem, you get a decimal, and then our answer was 9 square root 2. Should give us the same thing, and it does. So that tells you that, okay, same value, just a different way of writing it. So we're not changing value, all we're doing is changing the way it looks. So to rationalize the denominator, you have to get rid of the radicals in the bottom. So for number 4, 24 divided by the square root of 3. Ask yourself, what could we multiply by that would eliminate the square root? Well, you make it a perfect square by multiplying by root 3. But you have to do it top and bottom. Okay, so here's my fancy form of 1. In the top, we get 24 square root 3. In the bottom, this becomes the square root of 9, which is 3. Now again, last step is to ask yourself if you can reduce 24 divided by 3 is 8, so we get 8 square root 3. Okay, it's good. Now in number 5, the square root of 3 minus 9, that's the numerator. The denominator is 2 times square root 6. The problem is the square root of 6. So our focus is only on this denominator. To get rid of square root 6, let's multiply by root 6. But again, I have to multiply the top and the bottom by the same thing. Now in the top, we're going to distribute the square root of 6. Root 6 times root 3 is actually square root of 18. And then root 6 times negative 9 is minus 9 root 6. When I multiply the 9 and the root 6, I can't combine those. All I can do is just put them next to each other. Divided by, now in the bottom, the 2 will stay like it is. Root 6 times root 6 is 6. So that's 2 times 6. So what we have here is square root of 18 minus 9 root 6 over 12. Before we move to the next problem, though, we have to ask, is everything simplified? The root 6 is good because you can break it into 2 and 3, but you can't pull those out. However, the square root of 18 has some work to be done. On the side here, square root of 18, we can do a little factor tree, 2 times 9, and then 3 times 3. So that's the square root of 3 times 2. Now 3 times 3 is 9, that's a perfect square. So when I see that pair of numbers, I circle it, I'm going to pull it out. The square root of 9 is just 3, so what we get here is 3 square root 2. So I'm going to come back to my expression here. Square root of 18, that was 3 square root 2 minus 9 square root 6 divided by 12. Can we divide all 3 terms by the same number? Now, I'm not looking at the radical part. I'm not looking at square root 2, square root 6. I'm looking at the outside numbers, 3, 9, 12. So ask yourself, what goes into all of those? And the answer is 3. So we're going to divide each piece of this by 3. So, all right, I'm gonna write it up here, even though that doesn't really look great. 3 divided by 3, we get 1 root 2. 9 divided by 3, we get minus 3 root 6 over 12 divided by 3, which is 4. Now you don't really need the 1. I'm going to scratch that out. So we get square root of 2 minus 3 square root 6 divided by 4. You can only do this if you can divide every piece of this by the same number. If you can't, then you leave it like it is. Number 6, 48 divided by the cube root of 2. Now this is different because it's a cube root. So you got to think about what are perfect cubes. Well, if I multiply by cube root of 2 to get cube root of 4, that's not a perfect cube. However, 8 is a perfect cube. So think about 2 times what gives you 8, and that's going to be 4. So I'm going to say multiply by fancy form of 1, cube root of 4 over cube root of 4, and we get up top 48 cube root of 4 over, now the cube root of 2 times the cube root of 8 on the side, times the cube root of 4 is the cube root of 8, which is 2. Can we divide? Yes, we can. 48 divided by 2, you get 24 cube root of 4, and that's as far as we can go with that. All right, so now the second part of this, though, conjugates. Now we talked about conjugates the other day. Recall that when you multiply conjugates, 1 plus root 3 and 1 minus root 3, you double distribute. So 1 times 1 is 1. 1 times negative root 3 is minus root 3. Root 3 times 1 is positive root 3. And then root 3 times negative root 3. Now that's going to become minus square root of 9, which is really just minus 3. So we get 1 minus root 3 plus root 3 adds up to 0. Those are opposites. So I get 1 minus 3, which is negative 2. Now notice what happened is the radicals canceled each other out. The middle terms canceled. So we're going to use that technique to do something like number 7. 2 divided by the square root of 3 minus 5. The problem is this. I can't just say multiply by root 3 on top and on the bottom. Because if I do that, root 3 times root 3 is square root 9, which is 3. That's good. But then I get minus 5 root 3, so I still have a square root in the bottom, which is no good. That's not simplified. So I'm going to multiply by the conjugate square root 3 plus 5 in the top and the bottom. Now that's still a fancy form of 1. I'm multiplying by the same thing. Up top, I distribute, and I get 2 square root 3 plus 2 times 5 is 10. Now in the bottom here, I'm going to double distribute. Square root 3 times square root 3 is square root 9, which is 3. Square root 3 times 5 is plus 5 root 3. And then we're going to distribute minus 5 times root 3 is minus 5 root 3. Minus 5 times 5 is minus 25. Now in the denominator, 5 root 3 minus 5 root 3 is 0. So I'm going to cross that out, and what we get is 2 square root 3 plus 10 over, the radicals are gone, that's exactly what I want. 3 minus 25 is negative 22. Now ignore the radical number, square root 3, but look at the other numbers, 2, 10, negative 22. What can we divide out of all of those? We can divide everything by 2. Okay, so now in the top, what that will become, this 2 divided by 2, we get 1 root 3, and then this will be 10 divided by 2, which is 5, over negative 11. And the last piece of this, typically you'll see a negative go into the numerator for a fraction. So for example, if I say 4 over negative 3, typically you'll see it as negative 4 over 3, or they'll put the negative out front of the fraction. Okay? Same thing happens here. I'm going to put the negative in the top. But when I do that, it's like I'm going to take this negative 1 and multiply it up here. So I get negative root 3 minus 5 over 11. This is like a negative 1 times 11. I just put the negative 1 in the top, but again, it's negative. It's the opposite of both of these. Negative root 3 minus 5 over 11. And that's the answer. And now that's the end of part 1. So we'll finish up the last couple problems in part 2.